I'm not usually one to make YouTube videos, but I had to share this because I think it's pretty awesome. If there's any interest out there, I'll publish it. You do need a kind of beefy graphics card, so in this case I have an RTX A5000. You can get away with smaller, but you're not going to be able to train a very big model. What this is essentially is a way to train your own large language models, but everything is packaged here for you, so you don't need to um, explore the internet and figure out how this stuff works. You can kind of watch it happen and learn from experience. So anyway, the way it works here, I have a little brief that kind of tells you a little bit about the terms you're going to encounter. I'm probably going to add more to this in the different steps that we have to do to get through it. As you go through these tabs, you work your way toward your own model. So for example, if I click on overview here, I can see where I am on my current steps, and there's a whole entire what am I looking at that kind of explains it. I've been doing a lot here, so I'm already kind of through my process. I'm just doing training now. First step though is to sanitize your data. So you need to, you don't need to do this part, I should say, but if you have custom data sets you want to create, you can upload them here, and then you can clean your data set, and when you sanitize, you'll have it in here, kind of like this one here. I just picked a random Wikipedia article, and if I view it, I can see that it took the HTML and it converted it into text so I can train my model. That is something you can then send to the corpus, which is like your main training. So let's go look at that. If I go up here, here's the data set. I can pick my data sets from this list that I want to use to train, or I can, like you saw before, I can push in the one I created, and then you want to collect that data. It'll download it, and then you want to tokenize it. Tokenizing you only want to do one time though, and you want to pick your number carefully that you're going to do, like 32,000, or yeah, 32,000. That's basically how you're breaking up the words into tokens. If you have too many, then you end up with a model that's too big to run on your GPU. If you have too few, then it's not able to generalize, and it can feel more rigid and kind of dumb. So we get to the tokenizer. That's the next part once we have our vocab, or once we have our corpus. So now we create the vocab. I did 32,768. There's a math thing behind that, and it picks it for you. So that'll be your recommended, and then you can do a debug set if you want 8,000. That's not going to get you much, but you can always put in your own. All of this is pretty much correct, so I wouldn't mess with it. But what it's going to do is eventually spit out a tokenizer like this, where I can say convert it, and there we go, I got my tokens. So period is apparently 15 for a token. Anyway, once you have that, now we get to training, and that's where I am right now. I'm currently training my model. It's got a pretty good loss right now. It started at 10, but it's at 3.4 now. I'm 6,800 steps in, and I still have about 20 hours left to go on this GPU. It's taking about a fifth of the GPU to run this. Well, a fifth of the VRAM. It's maxing out the GPU. You can see right here. The thing is getting pretty toasty at 84 degrees Celsius, which is like almost 200 degrees. It's running at roughly 300 watts. It's just throttling a little bit whenever it gets too hot. But anyway, I can watch the data here as this green line approaches this blue line, and they both work towards 0. That's telling me kind of that I'm going in the right direction here. I'm training the data correctly. We really want to see the step loss going down, but right now you can see I've hit a valley where it's having a hard time knocking it down further. But overall, if I change the time step here to like 30 minutes, you can see it slowly working its way down. So there is progress, and you can see it happens in little curves here. If I go further, like say an hour, now you can really see that, although it looks slow, it is working. So that's good. And then the throughput and all that stuff, I just restarted the training, so some of the data is skewed here. If I go back down, you can see here, this is the tokens going through the model and how fast it's happening. It's, throughput tokens per second, 17,000. Learning rate is pretty much locked in. That learning rate can be fluctuated if we're stuck in a valley to try to get past that valley. But right now it's okay. GPU memory, you can see not anywhere near capacity right now. Graduated norm is just an indication of the fact that you're actually learning something. Same thing with perplexity, they're both kind of the same thing. We have the step time in milliseconds. That's how long it's taking it to, like how long it takes it to get to the next step. Right now it's averaging about 2 seconds, which is why this graph is kind of messed up. Every so often it does spike, and it kind of messes up the data. Tokens, instant. This is more of an instant reading. You can see there's these points where it has to recalculate where it drops down. Those are checkpoints. So every checkpoint it drops a little bit. That's okay. And then we have GPU utilization and temperature, just to make sure that you're not throttling on temperature. And then you have all your stats, and some raw data down here that you can just kind of watch it train. And you can see, like I said, if I, I don't have much data here, but if I went further up, you would see it started at 10, worked its way down to 3.5-ish, and it's still going. So once we have that going, we can stop whenever a checkpoint happens or take a checkpoint. And with that checkpoint, I can then skip these two for now, and I can go to the playground. And this is an example I did. I can't do it while I'm training, but I've already clicked it. So I can check my model. I can say latest medium checkpoint. And then what I did is I turned on mind view and generate. And this is a custom thing I made. First off, you'll see it's still kind of gibberish. It's like almost making sentences. Once upon a time, a small town had been built up for a long time. That's at least a sentence, right? So it starts to get a little repetitive, but we still have a long way to go on the training. We're only a few hours in on a 20-hour training. But here's the cool part. I have statistics. So you can actually watch it learn on the different layers here. This is actually showing activation of the neural network. So you can see there's the prompt input, which obviously is very much activated. And then we have, as it passes through the network on the different layers, you can see the activation is mostly happening toward the end. It's where the text is actually being generated. And then down here is just another view that kind of shows you that same data, but in a different spectrum. So you can just kind of look at how it's activating. And then the through pulse here is kind of showing you per layer as it's happening. You actually watch this build as it's going. So you can watch each token generate. So a line here is one token, meaning like a word or something. It looks like I cut it off just a little bit, but that's like a word, like maybe 2 or 4. And that's showing the activation that led to it through there. And you can actually see that here. For example, on activation 187, it was a 29% probability versus A was a 23% probability, so it picked the. But this is actually showing you what it was thinking about. It could have been any one of these if the percentages had changed. And as I go further in the training, it's going to become more clear to the model what it should pick. Right now, it's not so clear. And if I go up here again, let's go back to the big one. So this here is actually showing the model's brain when it was calculating that phrase. So I can see the different activation regions, and some of these might represent something like commas and periods, or one section might be numbers, one could be animals. How it breaks this up is really down to the model's choices. But if I go up here and we watch both at the same time, as I click here, or as I hover over number 4, it looks like lobe 4 is handling spaces and commas and periods. And it's just kind of making that choice. You can kind of see that. So punctuation, number 4 is punctuation. You get the idea, and you can kind of drag it around. You can see how different those activations are. They're completely different. They're way over here. And there could be other activators I'm not seeing here because I didn't encounter them. But every time you generate, you start to see these lobes form, and you can start to get a feel for how your model's brain actually works. So it's a small model. It's 350 million parameters, nothing too big. But I already put all the model parameters in there for you if you were to run this. So there's no need to really understand how it works. It's just using the latest information available, publicly available from research papers. So for example, if I go back to training here, if you wanted to do a different model, I have everything from debug, which good luck getting it to say a word or two. Medium is the one I'm training right now. And then as you work your way up, and I do suggest working slowly, you can get up to a large MOE, mixture of experts, which actually has multiple activators. So I think I did 8 activators, like eight experts, and 2 can activate at any given time. That's like the latest tech. Be careful, it's a billion parameter model, but it runs on a GPU pretty easily. Anyway, that's kind of what I got there. Again, I'm not publishing this yet. I want to clean it up, but I'm curious to see what people think about it. And last thing is the SFT. This is basically fine-tuning. So this is something I didn't understand until I did this. But corpus is like your corpus of knowledge. It's what you're teaching it. Whereas the SFT is the after processing. So once you have your model trained and the error rate is very low, SFT is where you go in to then give it instruction. So you're now telling it, okay, I want you to be to follow directions. I want you to look at this, like how people chat back and forth, and then you do a fine-tuning on that. And that fine-tuning then takes your now very knowledgeable model that can only repeat the next word, because remember, that's what we're seeing here. I gave it a few words, and then it just completed it, right? Well, once it gets to that point, that's not too useful, because we want to actually answer questions. And if I say, what is, what is a cat? It's going to just say, what is a cat, some philosophers may say. It's going to complete the sentence. so it's not going to actually answer your question. That's where this part comes in. So you want to make sure you have an SFT data set that you can then process after your model is now intelligent and can complete a sentence, and that'll teach it to answer question structure or other things. You could teach it on data sets or spreadsheets, whatever it is that you want the model to actually learn off of, or whatever behavior you want from it. And this is why you'll find these base data sets or these base models online that are not meant for instruction. And they'll actually say that, like, there's an instruction version or there's a chat version. The base version, really that base version is still just doing the basic next token. And then you have your specialists like these ones. That's also where you would train tooling. I don't have tooling here, but if you wanted to train it to use specific tool chains, then you would teach it how to use those chains here, and you would start training, and it would modify the weights of the model. Basically, these parts of the activation, it would weight them toward that type of behavior. And this is not like a system prompt, by the way. A system prompt comes way after all this. That's the programmer's job, or like the implementer's job when you're pulling the model down. This is in the neural network. This is very much a part of what the model is. It's entirely different. And then, of course, you can train that SFT. So that's the same kind of training environment here, same data. Haven't done it yet. But yeah, and you can always compare your models too. So if you have more than one model generated, I have this comparison set down here where I can pick any, like I can say, I want these two. It's training right now, so it's doing a bit of weird stuff, but you can actually compare the models and see how you're stacking up. If your model's learning, what is it learning? It's kind of interesting. So anyway, that's what I got. Let me know if you're interested in the comments, I guess, if you somehow stumbled on this, if I should publish it. I just don't know. I mean, with everything being so easily generated, does the world really need another software solution like this when you could spend $15 and do it yourself? I guess there is kind of an art to it a little bit because you kind of have to understand it to make it. But anyway, I'm rambling. Tell me if you enjoyed it.